I want to talk about how we can use recursion to model both loans or investments in math. So first situation, I put $5,000 in a bank. The savings account issues 2% interest once per year. So I'm just going to highlight that, 2% interest once per year, okay? Also, I deposit an additional $500 every year. So an additional $500 every year. Let's write a recursive equation that models this. The easy part is always to just say, well, where did it start? Well, it started at 5,000. You could either write u sub 0 or u sub 1 to model this. You'll see different textbooks do each thing, but essentially it's saying, where are we? Where did we start? We started with $5,000. Now, we always begin, of course, with un equals un minus 1 to get this year what happened last year. Now, we're getting 2%, so remember our kind of equation that we always used, and I used in previous videos, was we have 1 plus or minus an amount. And if we're losing value, we do 1 minus that percentage converted to a decimal. If we're gaining, we do 1 plus. Well, we're gaining here. We're getting interest. So we have to take our 2% and divide it by 100% to see, well, what is our decimal? And then put that in this box, 0.02. So that's what I'm going to multiply by. I'm going to put 1.02 in there, like that. But then I'm also adding $500 every year. So you get your interest and you add your 500. We're doing both things, okay? The question now is, how much money do I have after 3 years? Well, let's type this in and see. So we're going to put in that 5,000, hit enter. We're going to take that amount and multiply by 1.02 and then add that $500. So here's after a year, 2 years, 3 years, there we are, $6,836.24. I'm going to just slide that over and write that down as my answer, $6,836.24. Okay, next situation. I put $5,000 in the bank. The savings account issues 2% interest. I spelled interest incorrectly. Compounded monthly. So this all seems like it's the same, but then we have this little difference here that it's compounded monthly, but we're still putting additional 500. Here's what that means to us. We are taking that 2% and we are dividing it. I'm going to already write it as 0.02, the decimal. We got to have the decimal. We are dividing that by 12 because over the course of a year, you're getting your portion 12 times. So you're not getting 2% every month. You're getting a portion of the 2% every month. Okay, so that's what we're going to add to 1 instead because of this compounding monthly piece. That's where the 12 comes in. So if we said like compounding daily, we divide it by 365. If we said compounding twice a year, we divide it by 2. It's just dividing by how often we're getting that interest in a year. Okay, so let's start by writing my initial amount. And then we're going to write our equation to say, well, to get from 1 year to the next, I'm going to multiply. And I'm going to write it this way. Instead of kind of all of that decimal stuff, I'm going to do this. Just kind of show exactly what I did. And then add the 500. Okay? So again, we're just we're figuring out what portion of the 2% we get every month, adding that to 1. Again, just because we're gaining money, we do 1 plus. Then I'm adding the 500. Let's use the calculator to see how much we have after 3 years. Okay, so this one takes a little bit more typing, and I'll explain why. We're going to have our 5,000, and we're going to do the 1 plus 0.02 divided by 12. Okay? I'm not going to add the 500, and I'll explain why. This is after a month. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 months. then we add the $500. Okay. Now, I'm going to stop. This is a lot of typing. I just want to point out that after 1 year in the previous example, we had $5,600. Here we have 92 cents more than that. I know it's not a lot of money, but the only thing that changed was we got our interest more frequently. And only a portion of the 2%, but we did get it. So if I continued with this, I'd say, okay, I'd go back and I would redo it, with the multiplier 12 times, then add the 500. But for the interest of time, I'm just going to point out we made a little more money here. So let's talk about these two equations, investments and loans. We've already kind of talked investments, and loans, you're just going to see a subtle difference. So an investment starts with a principal. In my previous example, I put $5,000 in. Then to calculate how we get to the next amount, we take our 1 plus, because of course we're gaining money. We take the rate, in my example was 0.02, divided by how often per year we're getting that amount, that rate, multiplied by our previous amount, and then add my deposit. Okay? That's an investment. A loan starts with a loan amount. We're still being charged interest on that loan. They charge us for not paying it all off at once. So this part doesn't look really any different. But here, we're subtracting. We're not putting money into an account. Rather, we're paying off the loan. So we subtract off our payment, whatever we send in. Let's write a couple equations. I take out a $22,000 loan to buy a car. The annual interest rate is 7.9%, compounded monthly, and I pay $300 every month on the loan. So let's just highlight our information. 7.9 compounded monthly, and our payment is $300. So we can start writing the equation. Of course, we always begin with that initial amount. Again, you can write 0 or 1 there. Okay, totally up to you how you want to handle that. All right, so we begin with this. If you wanted to, sometimes people like to put the multiplier first. That was my general equation. I guess we're in the loans down here. Totally up to you if you want to do that, because, of course, multiplication, the order doesn't matter. Okay, so I'm going to multiply by 1 plus. Now we got to take our 7.9 and divide it by 100 to put it as a decimal. So it's going to be 0.079 over 12, because we were compounding monthly. And then we're going to subtract off our $300. Again, I'm going to put or here, because if you like to put the number first, it doesn't matter, but you could go with the formula I kind of presented if you like that more. Totally up to you. Okay. Now, I wanted to just type in a couple of months of this to show you kind of what was happening. Let me do that. All right, so you can see I'm starting with my $22,000 loan. I'm going to multiply that by my 1 plus 0.079 divided by 12, because I'm paying that over the course of a year, and subtract off my payment. So take a look at this. So even though I sent them $300, I still owe $21,844. So I've only paid off $156, even though I sent them $300, because of the interest. So you can see here, you're not going to go down by $300 because of that interest. Now, the lower you get, the more you pay this loan off, the more of that $300 will pay off the actual principal amount, the more you'll lower the actual amount that you owe. Okay, but when you are paying interest, you send them $300. That doesn't mean you owe $300 less on that car. So in the course of a loan, you end up paying a lot more than $22,000. All right, let's do another example. All right, we're going to put money into an investment plan each week, like when you get paid. And every week you're going to put $50 in. It's an annual interest rate of 4.795%, compounded weekly. So I'm going to write the equation here. We're starting off with $0, it looks like. Well, that's fair. That's how you start an account. And we're going to get our 4.75. So remember, we divide that by 100 to figure out what portion of 100% it is. And we're getting it weekly. There are 52 weeks in a year. And then we're also going to add $50. So, of course, that first month you don't have anything. You're going to put your $50 in. So there's your equation. And now, how much would you have in the account after 2 years? I don't want to calculate this for the sake of time, but I just wanted to point out that because we're doing this weekly, you know, there are 52 weeks in a year, you would have to set this up on your calculator and hit enter 104 times to figure that out, because each time you hit enter, each time you set it up, it's only giving you the next week. So sometimes these problems can take a while, and that's why often you'll see banks and things have computer systems that just set a loop and do this for you, and will print out a whole table of the values. They're often called amortization tables, and they'll help you see it because it's a hassle to do this by hand. If this video helped you, please like and subscribe for more math help.